Hi everyone, now it's time to talk about optimization. So what does it mean by optimization? Let's say in real life, you are given this much of material to build something, but you want to be able to hold as much as possible. So you want to be able to hold as much water as possible for maybe a container. So what should you do? How long this side has to be, how long that side has to be, that's optimization. Okay, so I have to be frank with you, this and the next one, rate of change, will be the most difficult topic in this whole chapter. And what I want you to do is to focus on other topics. Then eventually, if you have time, then you come back to do all this. Okay, so why do I say so? Because like the previous stuff that I talked about, what you can do, you do a lot of exercises, then you'll be able to score no matter what. You definitely can score. Like even if you think you're stupid like me, you still can score. Okay, why? Because that takes practice. But this one, it's a case by case basis. So if it changes a little bit of the case, like let's say it's like moving to the other scenario, then you might not be able to get it already. Okay, so you might not feel comfortable, hence you can't do this one. Okay, sometimes. Okay, I don't discourage you because this one, the steps that that involves here are not very difficult. It's just that maybe the question is very long, then you don't have the patience to read it and so on. Okay, so what you need to do is just that you listen to me and see my steps and follow my steps. So do some additional questions when you have time, then you can be ready for the exam. Okay, if you really can't do this in your exam, then at least you write down something that's important, or you know the few steps that you can do, and you write down. Okay, if you are aiming for 8, then this one, of course, you have to grab these marks as well, right? Okay, so without further ado, so let's move on to this. What is the problem? Okay, so you are instructed to construct a rectangle or a square with the sum of the sides is equal to 100 cm. Okay, the addition of the side will be 100 cm. Find the way to construct so that you will get a rectangle with the biggest area. So you are given this much of length. Okay, it can be total up of like 100 cm. You want to build the biggest areas, square or rectangle. So let's see. You have something like this: x, y, x, y. Okay. Because square or rectangle, it must be of this shape, correct? Okay, then what is the thing that is imposed to you already? You have this total up to be equal to 100. Means 2x plus 2y must be 100, correct? Okay, all right. So now, what is your problem? You want to maximize the area of this one. What is the area here? If you see this rectangle, x times y. So a is x times y. You want to maximize this function xy. Okay, so given that 2x plus 2y is equal to 100, that's the given material. So it can't be more than that. Okay, it can't be more than that. All right, so now let's say we trial and error. The first one, 30 and 20. So you get 30, 30, 20, 20, so you get 100. Okay, then what's the area for that one? 600 cm square. So this is 600 cm square. Okay, it's pretty good. Okay, let's try this. This is 40, 10. 10, 10, 40, 40, so you get 100 in total. So this one is 400 cm square. It's not as good as that one. So can you say that that one is the best one? Not really. Okay, you can go on and try this. 25, 25, 25, 25. Eventually you get, oh, it's even better than that one. It's 625 cm square. So for this case, I'll tell you this one is the one that maximizes the area. Okay, but how to solve it, we'll do it later. Okay, this one will be the one. Okay, now this is the problem. Okay, we are given a fixed material. We got to construct something with a criteria, like let's say here, maximize the area. Some other things is might be maximizing the volume and so on. Right, so this one will be the case. Okay, so we will talk about the why later. Now is what is the problem. Okay, so now Ali is given a string with length 100 to form a rectangle shape. Sorry, extra words there. To show show that the area of the rectangle is given by A is equal to 50x minus x squared. Alright, so B, to find the maximum area of the rectangle that can be formed. Alright, so if you can, then you pause the video. Of course, I think most of you, if you have not done this before, then I'll just proceed to talk about this one now. Okay, so now let's say parameter here, parameter is given by here, it's total up to be equal to 100 cm. Okay, that's given already. Okay, then 2x plus 2y is equal to 100, correct? So you see x and y, they are both having coefficient 2. So I cancel them off, so I get x plus y equal to 50. So if x plus y equal to 50, I want to find area. Area is xy. But if a function is given in terms of x and y, two variables, I'm not happy because I cannot differentiate and so on. So what I need to do is to write y in terms of x and substitute this one into here. Okay, and substitute this y into here. If I substitute y into here, then this one becomes what? A function of x already. So a is equals to x times 50 minus x. If you expand them, it's 50x minus x squared. Okay, then you get a is equal to 50x minus x squared. Okay, that's the first step. First step, if you want to maximize something, then you find the something. You want to maximize volume, then you find volume. But not just to find volume, simply find volume. You have to find volume or area or anything with one variable only. Other variables must be always replaced by things that can be replaced because of the restriction. The restriction here is that the parameter is 100 cm. That's why from here, you get y in terms of x, you replace here, so you get only one variable. Then you proceed to the next one. Okay? Then a is 50x minus x, right? Okay? Then we're done. So let's move on to the next one. So if a is 50x minus x squared, then what do? You differentiate it. Okay? You differentiate. Last time, what did we do? We find maximum or minimum. We differentiate it, set it equal to 0. So then we can justify that it's a maximum or minimum. Okay? So differentiate it is 50 minus 2x is equal to 0. Okay? Then I set it equal to 0. X is 25. Okay, then I want to see whether x equal to 25 is maximum or minimum. What do? I differentiate second time. So d square a dx square, d square a dx square. Okay, you do the square here, then a, then dx square. Okay, if you forget how to write it, square here and square behind. Okay, then it's equals to negative 2 because differentiate is negative 2. Negative 2 is always less than 0. Less than 0 means no matter what value you sub in, it's always positive. So it's always negative, so it's maximum. Maximum, hence this maximum area occurs when it's 25. When x is 25, so you substitute into the area formula. You substitute 25 into the area formula, then you get 625. Okay, then that's what happened here. Okay, all right. You have any problem here? Okay, so I just go back to the previous slide and come back to this slide and let you see what's happening here. Okay, so here, given parameter, the restriction, put into one variable, one side, sub into the maximizing function. You want to maximize area, then sub into that area, and maximize volume, sub into that volume. Okay, eventually, you must be only having one variable. After that, okay, get this function. What do? You differentiate it, okay, differentiate it, then set it equal to 0, then that's your maximum or minimum value, point, okay, point. Then this one is only the x value, okay, your area is this one, so you have to still sub this one back into A to get the area, the maximum area. This area happens to be the biggest when x is 25, means when this side is 25, it happens to be the biggest. What is y? Y is given in the previous slide, which is 50 minus x. Okay, so 50 minus 25. Okay, so this is 25. This is 50 minus 25, and it's still 25. Okay, so eventually this one will become a square. Okay, then you sub into that 25 into here, you get the area. Okay, then that's the maximum area that you can get out of those kind of material provided. Okay, nice. Next. A man wants to build a window with total outside perimeter of 60 feet, how should the window be designed to maximize the area of the window? Okay, so window is of that shape. Okay, so the design of the windows is shown below, is this one. Okay, so here pi x is this one. Okay, pi x is this one. What is it, pi x? Okay, you see here, this is x, then the whole perimeter of the circle is what? 2 pi x, because that's a radius, right? 2 pi x. Then, so this is pi x. Okay, so now what I do here, I want to maximize the area. Maximize area, so I want to write area in terms of a function. Okay, before that, I find the area. Okay, so if you can, you pause the video and try it. If you cannot, then you follow what I do. Okay, okay, shape is here. Then I write this parameter is equal to 2x plus 2y plus pi x. 2x plus 2y plus pi x is equal to 60. Okay, from here I need to go on to substitute into the a, right? A here. Okay, later on the a. So I can only have one variable. So I put y on one side and x on the other side. So 2y is equal to 60 minus 2x minus pi x. Then y is equal to 30 minus x minus pi x over 2. Okay, great. So now, let's see here. Area of this one. Can you tell me how to find the area for this? So here, this is 2x, this is y. So this rectangle has area 2xy. 2xy. So that's the area of that rectangle. How about this one? This is x. Okay? This is also x. So this is pi x squared divided by 2, because it's a circle, pi r squared divided by 2, because it's only a semicircle. Okay, let's see this. 2xy plus pi x squared. This is a circle divided by 2, so it's a semicircle. So it's this one. So do you see that there's a y here? So you can't have any a that you want to maximize having two variables. There can be only one variable. So for this case, you put it as y sub into here. After you sub into here, expand it, right? Nicer, right? Nicely. Okay. Again, write it neat. Then it's given by this one. Okay. 60x minus 2 plus pi over 2 bracket x squared. Don't change this pi to be equal to 2.14 something. It will distract you further. You just leave the pi over there. Okay. Treat it as a constant. Just don't care about this. If you want to differentiate everything, it's fine. You just differentiate x squared is 2, then x here. Okay? So now, we are kind of done for this one. We are kind of done. We leave here, this one as our a. Okay? Then, what we do here is to find the maximum, right? You want to maximize this function. Now the function is given by this one already. So a is given by this one. The nicest form that we can find. Then we differentiate it, set it to be equal to 0, and that's our maximum. Okay, then that's it. Easy as that. 60x differentiate, I get 60. This thing x squared, so I write 2 in front, then x. 2 and the 2 becomes 4. 2 and the 2 will be cancelled. So it's 4 plus pi. Okay, I set it to be equal to 0. I think you can easily do it right. You move this one over, divided by 4 plus pi. So x will be 60 over 4 plus pi. Then you calculate the number. Okay, it's better here this way. Okay, this is the this is the thing. Okay. All right. So what does it mean? You only find x, right? Okay. If you are needed to find the maximized area, then you have to sub this back into this one, a. Okay. This is x. The area is maximized when you have x equal to this value. Okay. You want to find the maximized a, you substitute this back into a. Okay? Okay, next one. Here, a physical fitness room consists of a rectangle with a semicircle on each side. So it means that this is semicircle, this is semicircle. Okay? If parameter of the room, sorry, this is a room, one more O, is to be 200 meter running track. Okay, find the dimensions that will make the area of the rectangle region as large as possible. So area. Okay. A rectangular region. So something like this one, this whole thing. Okay. So now what you need to do, you want to maximize area given that the perimeter is 200 meter. Okay, great. So now, so this one is the answers. If you can, you try this yourself. If not, you move on. Okay. So pause the video and try this. Try this now. I think we have done like 2 questions already. So this one you can try it. Okay. If you really cannot, then we move on to the next. Okay. So now total walk around distance is 200 meter. Then perimeter here is this one. See, x plus 2 pi y over 2. What am I doing here is that here. What is this? This is y. Then half of it is y over 2. Then this semicircle plus this semicircle will become one circle. Okay, one circle. So circle the perimeter is what? 2 pi r. 2 pi times this one. So what do I get? 2 pi times this one. So okay, that's what I get. Okay, I simplify it right nicer. So 2x is plus pi y is equal to 200. So again, I want y to be staying on one side because later on I don't want to have y anymore. Okay, area. Area is xy. xy, because I want to maximize this one, right? Okay, I want to maximize the rectangular region. Okay, just now the question stated that I want to maximize the rectangle region here, which means that maximize xy only, not the whole thing. Okay, just be careful about the question. Huh? Okay, so I want to maximize xy. Y I replace by this one. I put it here. Then I simplify it nicely. Then I'll get this one. Okay, it's nice enough. Now, what do you need to do? Maximize. So I differentiate and make it to be 0. Okay, differentiate and make it to be 0. So this one will be equal to 0. Okay, you have any problem? From here you differentiate. You see 200x. So 200, nothing, right? 2x squared becomes 4x. The constant you put outside, never change anything. Okay, then this one is equal to 0. So means this one is equal to 0. Okay, this one is equal to 0 means what? You have you multiply pi both sides, then it's gone. So pi times 0 is still 0. So 200 is equal to 4x. So x is equal to 50 meter. Okay, x is equal to 50 meter. Okay, then that's your answer. If you want to know the maximum area, then take this, put it into here, or put it into here, then get the answer for that. Okay. All right. So any problem here? Okay, let's move on to the next one. This diagram shows a right angle triangle. So right angle triangle means this one, 90 degree. Okay. Given that the total length of AB and AC is 20, so show that the area of a triangle is given by A is equal to 10x minus x squared over 2. Then find the maximum area of triangle. So this one will be the answer for B. Okay, A max. Okay, pause the video and try this. Now, I'll solve this question for you. Okay, let's do it. So now, you know x plus y, total length of AB and AC is 20. So x plus y is 20. X plus y is 20. Okay, so now y is then 20 minus x. Okay, no problem? Great. Next, so now I have what? The area of this one, area is equal to x, y over 2. Area is x, y over 2. So x is x, y is that one, 20 minus x, then over 2. So what do you have? This one cancel off, so it's 10x minus x squared over 2. So forgot to write the x, minus x squared over 2. Then I get my answer. Okay, 10x minus x squared over 2. I get this. So my area is in terms of one variable, is this one. Okay, great. So if I have this one, I'm going to find the maximum area of the triangle. Easy. I differentiate dA dx equals to 10 minus 2x over 2. I set it to be equal to 0. So 2 and 2 cancel off. So 10 minus x equals 0. So x is equals to 10. Am I done? No, I'm not done, because I only find this one is A is maximized when x is equal to 10. I haven't found the maximized area. So in order to find the maximized area, what do? I sub the x into A. So when x equals to 10, okay, I sum into here. So it's A equals to 10 times 10 is 100. 10 squared is 100. Divided by 2 is 50. So minus 50. So it's equals to 50. What is the unit here? A. And here it's m, right? Meter. So 50 meter square. 50 meter should be square lah. Okay. Sorry about it. Forgot about the square here. Okay. So that's the answer. A max. Okay. Maximize A will happen when x equals 10. Okay. Should be having no problem, right? Right. Let's move on to the next one. Okay. So this diagram shows a closed cylinder with height h and h meter and radius r meter. Given that the volume of the cylinder is 16 pi m cube. Again, don't disturb this pi. Leave it as pi first. Eventually, if you want, you can change it to number, but don't do it during the steps. You will make it very, very messy. Okay. Show that the total surface area of a cylinder is given by this one. This is the first question. Second question is to find the minimum value of A in terms of pi. So is that one? Okay. So it's given here, the answer. If you want to try, you can try it. If not, you just move on to the answers. Okay. Right. So first of all, show the total surface area is this. So first of all, volume is given by what? Volume is given by pi r square h. So 16 pi. This one is given. Volume of cylinder is 16 pi m cube. And you know the volume is pi r square h for a cylinder. So you equate them and pi can cancel off. So you get r square h is equals to 16. Now you be careful, because here you can choose one to put in one side, right? If you put r on one side, then you have a positive negative square root. You do not want to have positive negative square root. So that's why you let h to stay on one side. So here, instead of putting r on left hand side, you put h on left hand side so that you don't have to disturb the square there and make it to be positive negative square root. So h is 16 over r square. Okay, good. Then now, what do we need to do? Is to find the surface area. Surface area, here, you see, a cylinder, you have a top circle, bottom circle, plus another circle, then plus this thing, right? This middle thing, okay? If the middle thing, I just open up, then it becomes a rectangle. Do you see that? This middle part of a cylinder, I open up. If I open up, then this side is h. And how about the top part here? This circle, if you open up to be like a long one, so it's a perimeter of the circle. So it's 2 pi r. Okay? No problem, right? This one? Okay? I think graphically you see this one, then it's more appealing. Okay? And now, can you tell me what's the area of this? Yes, pi r squared. So pi r squared plus 2 pi r h. 2 pi r h. Now, what do you have? You have r, you have r and h. H, you can use this one to put it here to replace everything. And I put the h over here, and I get this one. So I simplify a bit. I get 2 pi r squared plus the 32 pi divided by r. So, which is the answer here. Okay? Great. Okay? So, it's not very difficult, right? If you know all those, if you know this small formula like the volume, the surface area, how to find, then it's not really difficult. Okay? I move on to the next part. Now, you want to find the minimum value of, in terms of pi. Okay? In terms of pi. So, you can't change it now. So, A given this one, or you have found it already. In the exam, you know, like in the exam, maybe there's a first part to show. Second part is to find the minimum value. What do you need to do if you don't know how to do first part? You just take this part from A, then just differentiate, make it to be 0, find the answers. Okay, so you can't do first part, you do second part. Okay, you don't have to give up the whole question. Okay, so now I'll show you how. What you need to do, differentiate with respect to R because there's only one variable. Differentiate, I get this one. I'm one step further. If you still can't get this one, you have to think about this one. 32 pi over R means 32 pi as a constant, then differentiate 1 over R, right? Okay? Differentiation of 1 over R, ddr of 1 over R, remember what I said last time? Is negative 1 over R squared. Because this one is what? R to the power minus 1. This one is what? Negative R negative 2. Okay? If you cannot do that one so fast, then you do this one. It's fine. Okay? I differentiate. I set it to be equal to 0. Then I solve for it. How do I solve for it? Because here is R, here is also R. I make them having the same denominator first, R squared. Okay? This thing, top and bottom equals 0. Then top must be equal to 0, right? Bottom, you just multiply both sides by R squared, then it's gone. Okay? So you got this one equal to 0. Okay? Then R cubed minus 8 is equal to 0. Do you get this? I divide both sides by 4. Then I divide both sides by 4, I get this one. So my R definitely is equal to 2. Okay? In the exam, they just ask you to find the minimum value. You found this one, actually there's no need to differentiate second time. Okay? You just find this one, set it to be equal to 0, you get this answer, then it's fine. Okay? Then that's done. Okay? You want to find a minimum value of 8, you have not done yet. Because you only find the value when it's maximized or minimized, which is R equal to 2. Okay? The 2, you have to substitute in back here, then you get the answer. Minimize when R equal to 2. Okay? Then this one, and you get 22 pi m to the power 3. Okay? You know, like it's a bit cheating here because like in SPM, the textbooks and so on, you just want to find maximum value or minimum value, then you differentiate, you set it to be equal to 0. You don't check whether it's maximum or minimum, then you directly conclude, okay, substitute in, okay, that's minimum value. If the question asks minimum, then that's a minimum. If the question asks maximum, then that's maximum. So in future, after SPM, there will be other things that you need to verify. Those kind of things is indeed a maximum. But for this time, for this level as SPM, you just leave it as it is. Okay, so treat this as that is the answer. All right. Okay, number 6. There are a lot of questions here because it's one lesson on this whole thing. So I'll just squeeze it in one lesson. So you need this lesson, then you come back to look at this. Okay, so this diagram shows a cuboid. So cuboid looks like this one. Okay, and has a square base. Okay, the total surface area is 216 cm square. Show that the volume of the cuboid is given by this one. Shouldn't be too difficult. Find the maximum value of V. Okay, V maximum is given here. Pause the video if you want. If not, I'll solve it. This one, very simple. Total surface area. Okay, 2 times this square with xx, then plus 4 times this one, xh. You know what this means? 2 times this one means what? Which one? This one and this one. 4 means 1, 2, 3, 4. Okay, the sides. Okay, the sides are this. Okay, 216 is given here, cm square is equal to 2x squared plus 4xh. Then I have this one. I simplify a bit. Then I want to make one thing on the other side. Again, you see x and x squared here. It's very difficult to do that, right? Put x on one side. And it's not possible for this case. So you put x on one side and leave it with h on the left hand side. Okay, so h is equal to 108 minus x squared over 2x. Alright, then now volume of this cuboid is x squared h. Okay, no argument, right? X squared times the height, then it's the volume. So x squared, leave it unchanged, h change it to that one, and I can cancel off things, then I'll just get 54x minus x cubed over 2. Okay, so find the maximum value of V. So V is given by this one, differentiate it. Differentiate it, you get, make it be equal to 0. So x squared is equal to 36, so x is equal to 6. In fact, x squared equal to 36, then x should be equal to positive negative 6. But the problem is that x is what? X is the length of a side. So it cannot be negative, right? Okay, so x should be 6 only, okay, 6 cm, right? Then next, when FV is minimized, when x is 6 cm, okay, actually this is maximized, okay, maximized, okay, sorry, when x is 6 cm, and then what you do, you just substitute this 6 into that, then you get an answer, okay, and it's 216 cm cube, okay, no problem with this. We move on to the next one, last one here. So frame below formed by using a piece of wire of length 120 cm, show that the area is given by A equal to 360 x minus 36 x squared. Find the value of x that makes A a maximum, and C determine the maximum area of the frame. Normally we do B and C together, but this question is separate, so it's fine. So answer is given here, and pause the video to try it. If you can't, if you have tried and you can't, then we do it now, right? All right, so the area is given by this, easy. So perimeter, what we do, we add up everything here, y, 6x, 5x, 5x. So I get it total, and perimeter is 120 cm. So set it to be 120. Simplify it, so I divide by 2, I get this one. So y can be nicely stay on one side, so I put y on one side. Okay, y is equal to 60 minus 8x. Next, area is 6xy plus 6xy should have no argument because 6x times y is the area of this rectangle. Then the other part here, you might have difficulty finding the area there. What is the area? So you want to find this one, right? Okay. So what I do, I zoom this one, put it here. Okay. So this is 3x. Do you have any problem with this 3x? Here the whole thing is 6x, correct? Then half means 3x. 3x, 5x, this one should be what? 3, 4, 5, right? 4. But why is that 4? Because this is a right triangle and you should use Pythagoras theorem. Pythagoras theorem tells you what? This thing square minus this thing square is equal to this thing square. Or like normally how you do, a square plus b square is equal to c square. So here will be square root 5x the whole thing square minus 3x the whole thing square is equal to 4x. Okay, you take square root is equal to 4x. Okay, get that? Okay, so now you see, if you get this side as 4x, this side as 3x, so this whole thing will be 12x squared divided by 2, because base times height divided by 2. Okay, you get this one. But now you have two pieces of this one, because one piece, two pieces. So it's 2 multiplied by this one, hence you get 12x squared for this whole thing. Okay, so here 6xy plus 12x squared. Okay, then you have a outlier here, an alien here, y. So you sub that y into here, you get 60 times 6x times 60 minus 8x plus 12x squared. So it's 360x minus 36x squared, right? So the only difficulty will be here. So if you can't do this one, pause the video to digest this before you move on. If not, we will move on to the next one. Okay, find the value of x that makes A maximum. So you just directly differentiate it, right? Differentiate it, make it be 0, then solve for x. Very simple. 72x is 360, press your calculator, x is 5 cm. Okay, what does it mean? It means that the area is maximized when x is 5 cm. Okay, next, determine the maximum area of the frame. Maximum area of the frame, so it means that we substitute this maximized x value into the area A. A is given by this one, then we get an answer. Okay, substitute, put it in 900 cm squared. Okay, then that's what your answer is. Okay, A max is 900 cm squared. Okay, you get the answer? Happy with this? Okay, so try to do more questions if you have time. Do like if you see some kind of different questions that popping up from your friend or some other textbooks, then just try to see whether you can do it or not. Okay, if you want to try to score for this one, then you have to try to get more exposure to more different types of questions. Okay, but I have to tell you that the priority should be the previous stuff. Okay, all the things other than this one and rate of change, okay, should be your priority. So after those kind of things you have mastered, then you come back to do this, okay, it will be better, okay. So I'll see you next class. See you, bye.